Hi everyone, myself Dr. C.H. Shashi Kumar, working as an assistant professor in VIGNAna JYOTHI Institute of Engineering and Technology. Today we are discussing about Laplace transform. So Laplace transform is a function which is defined for all positive values of t. Then Laplace transform of f of t is defined as improper integral 0 to infinity e power minus st f of t dt provided the integral exists where s is a real or complex number. That means the purpose of using this Laplace transform is whenever if we have any complex time domain function, we have to convert into a simple algebraic simple algebraic frequency functions. To find out the Laplace transform, we have to follow some sufficient conditions. That is, first one is the function f of t is a piecewise continuous, and second point is it is an exponential order. So the meaning of piecewise continuous is you can take as a function which is defining in the interval a to b. If we clearly observe that the function a to b, it is a discontinuous function, we can call this a jump discontinuous function. The function a to t1 is exist, t1 to t2 is exist, t2 to t3 is exist, and at the point t3 to b also exist, but at particular point t1 t2 t3 the value is a jump continuous. So we can call this a discontinuous function. So that discontinuous function they are trying to convert into a piecewise continuous and exponential order. Here you can take two functions f of t and m into exponential function m into e power ct. That blue line representing as a f of t function, red line representing as a exponential function. Here the value of after particular time t, the value of f of t is having as a less growth comparing to that exponential function. We can call this a exponential order. Suppose the value of f of t, the function f of t increase rapidly comparing to that exponential function, we can't say it is a not exponential function. Simply we can call as how can we define as exponential order is limit t tends to infinity e power minus st into f of t, that value is goes to a finite, we can call exponential order. If this value is goes to a infinite value, we can call as a not an exponential order. By using this Laplace transforms, we can solve different applications in different branches. Like you can take as a applications in engineering branches, in CSE, IT, AML, data science, control systems in AI robotics. In controlling systems and AI robotics makes a real-time decisions. For example, self-driving car systems to adjust speed and directions. Signal processing in computer vision. In this Laplace transforms for edge detection and noise filtering we use. Example, you can take a face recognition software use Laplace based algorithms only. And algorithm analysis. In algorithm analysis, if you want to solve the recurrence relations in complexity analysis, we use Laplace transforms. Cryptography used in encrypting and decrypting the message by transforming the signals, for example, secure online banking transactions. And in machine learning and neural networks helps in differential equations in deep learning models, for example, optimization of neural network weights. In ECE, EEE, and electrical branches, we are using Laplace transforms in different field, like circuit analysis helps in analyzing electrical circuits including RLC circuit, for example designing filter in audio equipment. In control systems used for feedback control in automation and industrial systems. In signals and image processing used in sound and image filtering to remove noises. In communication system using analyzing the modulation techniques like AM, FM, and digital signals, for example, used in wireless network transmissions. In power systems, helps in transient analysis of electrical network, for example, preventing power surges in electrical grids. Embedded systems and VLSI used to analyze response times of digital circuits, like microprocessor chip designing. In mechanical engineering, vibration analysis used to study damping and forced in mechanical system, like Laplace transforms helps in enabling engineering to analyze damping effects and resonance frequencies. In control of mechanic system, used Laplace transform to design controller for stability and precisions. In heat transfer, used in thermal system modeling to analyze conduction, convection, and radiation problems. In fluid dynamics, Laplace transform simplifies the Navier-Stokes equation, making fluid flow analysis easier. In stress analysis in material, the structural stress and deformation can be modeled using Laplace transform, improving material durability predictions. In automobile engineering, vehicle suspension design and dynamical stability analysis. Similarly, for civil engineering branches also, structural analysis, Laplace transform is used to analyze loads on building and bridges, ensuring structural integrity. In seismic analysis, helps model earthquake forces and vibrational, aiding in designing earthquake resistant structure. In hydrology and fluid mechanics, used in analyzing water flow through dams and pipeline to optimize fluid dynamics. In traffic engineering, Laplace transforms applied traffic flow modeling to optimize road designing and reduce congestion. As we have seen, Laplace transform plays a crucial role in analyzing mechanical vibration, heat transforms, structural analysis, and even traffic flow. Its ability to simplify complex system makes into a powerful tool in engineering. So to apply the Laplace transform, we have to know the basic formulas of the Laplace transform. So Laplace transform satisfy the linear property condition. That means, suppose if C1, C2 are two constants, then Laplace transform of C1 into f of t plus C2 into g of t is equal to, we can write C1 into Laplace transform of f of t plus C2 into Laplace transform of g of t. It must satisfy the linear property condition. Now we'll try to find out the basic standard Laplace transform of the function. That is, first one is Laplace transform of 1 is equal to 1 by s. So already we know that Laplace transform of f of t is equal to, by definition, we can write this value as 0 to infinity e power minus st f of t dt. By using the definition, in place of f of t, we are taking as a 1 value. So Laplace transform of 1 is equal to integral 0 to infinity e power minus st into 1 into dt. Now integrating, integral of e power ax is e power ax by x, e power x by a. That means e power minus st by minus s, where the value of t varying from 0 to infinity. Now we know that when t approaches to infinity, e power minus st, that is approaches to e power minus infinity, that is approaches to 0 value. When t approaches to 0, then e power minus st approaches to e power minus 0, that means 1 value. So by applying this upper limit value, when t approaches to infinity, 1 by infinity is 0, minus when t approaches to 0 value, that value is 1, 1 by minus s, that is equal to 1 by s. So that means Laplace transform of 1 is equal to 1 by s. Similarly, Laplace transform of k is equal to, we can write k by s value. Next, Laplace transform of t power n is equal to n factorial by s power n plus 1. By definition of Laplace transform of f of t, we can write integral 0 to infinity e power minus st f of t dt. We will take Laplace transform of, in place of f of t is equal to t, then integral 0 to infinity e power minus st t dt, that is equal to t into e power minus st by minus s, minus derivation of t is 1, double integral of e power minus st, e power minus st by minus s whole square, where the value of t is approaches from t equal to 0 to infinity. In the previous we said, as t approaches to infinity, e power minus st is approaches to 0. When t approaches to 0, e power minus st approaches to 1 value. By applying this, we will get upper limit is 0 minus lower limit is 1 by s. Here is s square you will get. 1 by s square. So that means Laplace transform of t is 1 by s square. Similarly, if you calculate Laplace transform of t square, you will get that value as 2 by s cube. Laplace transform of t cube is equal to 3 factorial by s power 4. Like that, if you continuing this, Laplace transform of t power n is equal to n factorial by s power n plus 1, where n belongs to positive integer. Suppose if n is not a positive integer, then we can write Laplace transform of t power n is equal to, we use as a gamma function, gamma of n plus 1 by s power n plus 1. What is gamma of n plus 1 is n into gamma n by s power n plus 1. So like that, we can write n factorial by s power n plus 1. Depending on the value of n, we have to go for the direct formula n factorial by s power n plus 1, or if n is not an positive integer, we can go for gamma of n plus 1 by s power n plus 1. And the negative value of gamma is not defined. Gamma is not defined for the negative values. Next one, if we are taking as f of t is equal to e power at, then Laplace transform of e power at is equal to 1 by s minus a. So here we are taking f of t is equal to e power at. Now Laplace transform of e power at is equal to, we can write 0 to infinity e power minus st e power at dt. We can simplify this as 0 to infinity e power minus of s minus at dt. Now integrating this, e power minus of s minus a into t by minus of s minus a, where the value of t approaches to infinity. Applying the upper limit value, e power minus infinity always goes to 0, minus lower limit value is minus 1 by s minus a, which implies Laplace transform of e power at is equal to 1 by s minus a, where the value of s is greater than a. Similarly, we can also write Laplace transform of e power minus at value as 1 by s plus a, 1 by s plus a. If it is a trigonometric function, if f of t is a trigonometric function, we can first calculate what is e power it. In the previous, we have seen e power at is equal to 1 by s minus a. Now e power I into at, how can we write? That is 1 by s minus ia. Now multiplying and dividing by s plus ia, that is s plus ia by s plus ia into s minus ia. That is equivalent to separating that real and imaginary part, s by s square plus a square plus I into a by s square plus a square. By using de Moivre theorem, we can write Laplace transform of e power iat is equal to cos at plus I sin at. Now separating that real and imaginary part, once again, Laplace transform of cos at is equal to s by s square plus a square, and Laplace transform of sin at is equal to a by s square plus a square. If f of t is a hyperbolic function, then Laplace transform of sin hat is a hyperbolic function, that you can write as in terms of a exponential function as e power at minus e power minus at by 2. That is equal to 1 by 2 into Laplace transform of e power at minus e power minus at. This value is equal to 1 by 2 into Laplace transform of e power at minus Laplace transform of e power minus at. That is equivalent to 1 by s minus a minus 1 by s plus a. Once again simplifying this by taking as LCM as s minus a into s plus a minus s minus a, that is equal to 1 by 2 into 2s by s square minus a square. Sorry, 2a by s square minus a square. That is a by s square minus a square. Similarly, for Laplace transform of cos hat is also we can write as e power at plus e power minus at by 2. That is equivalent to 1 by 2 into Laplace transform of e power at plus Laplace transform of e power minus at. Laplace transform of e power at is 1 by s minus a. E power minus at is 1 by s plus a. Once again, taking the LCM as s minus a into s plus a, s plus a plus s minus a, the quotient. So 1 by 2 into 2s by s square minus a square, that is s by s square minus a square. So these are the basic formulas to solve the differential equations. Once again, you can see what the formulas for Laplace transform is. Laplace transform of 1 is equal to 1 by s. Laplace transform of t is equal to 1 by s square. Laplace transform of t power n minus 1 by n minus 1 factorial, you can write as 1 by s power n. And Laplace transform of e power at is equal to 1 by s minus a. E power minus at you can write as 1 by s plus a. Cos at s by s square plus a square. Sin at a by s square plus a square. Cos hat is s by s square minus a square. Sin hat is a by s square minus a square. We'll take some problems. How can we apply this Laplace transform for the basic functions? We'll take as one example. Find the Laplace transform of e power 3t plus sin 2t plus cos 2t plus 2 square. When we apply Laplace transform, we can write L of e power 3t plus sin 2t plus cos 2t plus t square. By using linear property, we can write as L of e power 3t plus L of sin 2t plus L of cos 2t plus L of t square. Laplace transform of e power 8 is 1 by s minus a. E power 3t is 1 by s minus 3. Sin 2t is 2 by s square plus 4. Cos 2t is s by s square plus 4. Laplace transform of t square. T power n is n factorial by s power n. T power 2 is 2 factorial by s power 2 plus 1. It is s power 3. We'll take one more problem. Laplace transform of sin 2t cos 3t. Laplace transform of sin 2t cos 3t. So when we have a product of two trigonometric functions are there, we have to apply the trigonometric formula, that is 2 sin a cos b formula. So 2 sin a cos b is equal to, we can write as sin of a plus b plus sin of a minus b. That is, we can write 1 by 2 into Laplace transform of 2 sin multiplying and dividing by 2 cos 3t, that is equal to 1 by 2 into, apply the formula sin of a plus b plus sin of a minus b, that is sin of 2t plus 3t 5t plus sin of a minus b. A minus b is 2t minus 3t. 2t minus 3t is sin of minus t. We can write 1 by 2 into Laplace transform of sin 5t plus sin of minus t is minus sin t. So we can write minus sin of t. Now Laplace transform of sin 5t. Sin 8 is a by s square plus a square. Sin 5t is 5 by s square plus 25 minus Laplace transform of sin t is 1 by s square plus 1. Next, cos square t. Find the Laplace transform of cos square t. You know that Laplace transform of cos t, but cos square t if you are calculating by using as a trigonometric formula, once again you can write of Laplace transform of cos square t as 1 plus cos 2t by 2. That is equal to 1 by 2 into Laplace transform of 1 plus Laplace transform of cos 2t. That is equal to 1 by 2 into Laplace transform of 1 is 1 by s. Laplace transform of cos 2t is s by s square plus 4. So like that you can take any function, we can convert into a simple, our known basic formulas, we can easily calculate the Laplace transform. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.